My name is Archita Garag. Topic I have chosen for my digital assignment 3 is probabilistic analysis and hiring problem. So what really is probabilistic analysis? It is basically the probability to analyze our algorithms. So it is the approach to estimate the complexity of an algo or a problem, and it usually starts from assumption about the distribution of a set of possible inputs. And this assumption is then used to design the algorithm. So what basically is the hiring problem? So in the hiring problem, a person is trying to hire an assistant, and that person employs an agency to send them one candidate every day. Now, if the candidate sent by the agency is better than the current assistant that the person has, he will pay out the current assistant and then hire the current candidate as a new assistant. So here is the algorithm for the hiring part, where n is the total number of candidates, and if the current candidate is better than the candidate, if the current candidate is not better than the candidate that we have hired, then we hire the candidate that has been sent by the agency. So in the hiring problem, usually in algorithms, we are mostly worried about the time complexity of the problems. But since in the hiring problem, we are hiring an agency and then paying out our current assistant or hiring a new candidate, we are using cost. So we need to more worried about the cost of the algorithm rather than the time it takes. So let's say CI is the cost it takes for interviewing the candidate. CH is the cost needed to hire candidate, and so here we have got n candidates, and let's say we have hired n candidates. So what the total cost here would be n into Ci plus n into Ch as shown here. So what would be the worst case in this scenario? So worst case would be that the candidates that are coming are in increasing order of quality. Like let's say today candidate 1 have had candidate 1, next day candidate 2 is better than 1. Next day candidate 3 is better than 2. So I have to hire a new candidate every day. So in this case, the total cost here would be n into hiring cost plus cost of interviewing the candidate, since we are hiring and interviewing every candidate. Now, what would be the best case for this problem? The best case would be that the first candidate that we do it is the best candidate among all n candidates. So here, the cost here would be n into Ci, because we are interviewing every candidate, plus Ch, that is the first candidate that we hire. So what would be the average case for this problem? The average case for this problem would be if candidates of different quality come in random orders. Now, to solve this problem using probabilistic analysis, we will be using something called an indicator random variable. So what is an indicator random variable, or the IRV? So IRV is a method to convert probabilities and expectations. So let's say let the variable let's say there's a variable I of A, where A is an event, and if A occurs, I of A is 1, and if A does not occur, I of A is 0. So to calculate expectancy of this I of A, the formula for it would be 1, which is the probability for A to occur, into the actual probability whether A occurs or not, and plus 0 into P of if A does not occur. So how do we solve hiring problem using the IR? So let's say X is a random variable to denote the number of times we hire a new assistant, and let Xi be the IRV for the ith candidate. So Xi is 1 if the candidate is hired, and it's 0 if not hired, as we had seen in the previous slide. So X, that is the total random variable, would equal to the x1 plus x2 plus x3, which will go up to x to the xn. So expectancy of this event would be the probability of the candidate being hired. So for the candidate to get hired, like let's say ith candidate should be better than the candidates than the previous candidate. So that would be 1 to I minus 1. So the probability of a candidate being hired would be equal to 1 by I. So now coming to the expectancy E of X, as we had seen in the previous slide, X is equal to X1 plus X2 plus X3 till Xn. So calculating expectancy of this part, E of X is equal to E of X1 plus X2 plus X3 till Xn. Now substituting I value for with 1, 2, 3 and so on. Summation of this would be log of n plus O of 1. So now our average case now becomes O of CH into log of n. Now this CH of log of n is much better than our worst case. So we have seen an improvement in our cost. So our hiring problem has been solved using probabilistic analysis. Thank you.